Hey guys, in this one I'm going to explain to you the concept of taking the derivatives of trigonometric functions and their reciprocal functions, and as well show you some examples. So let's start with the most basic one. So the derivative of of sine x, so here, let me do it easier. d dx of sine x, right, is equal to cos x. Okay? The derivative of cos x is negative sine x. Okay. The derivative of tan x, which is just sine over cos, right, is secant squared x. Right. The derivative of secant x is equal to secant x tan x. Okay. The derivative of cotangent x is equal to negative cosecant x, cosecant squared x, and the derivative of cosecant x is negative cosecant x times cotangent x. Okay, these are identities that you're going to have to memorize because proving them with the limit of h approaching 0 of like sine x is just way too time consuming, and it requires a lot of trigonometric identities, and it's just a hassle. It's not worth doing it every time, so it's good to memorize them. And you kind of see a pattern, right? Like some of them are very similar, like the secant one and the cosecant one are always pretty similar to me because they're the only ones that are two terms. So just find a good way to memorize it for yourself, right? So let's do some examples. So this one, so f prime of x, the constant is not affected. Secant, so secant is equal to secant x tan x, so we just put that. Secant x tan x minus, the tan is not affected, cotangent. What's cotangent? Cotangent is times negative cosecant squared x, right? Okay, that was pretty easy. Let's do another one. Okay, so this one is a polynomial, not a polynomial, rational function. So 3x to the negative 4, we're going to subtract 1. So 3x to the negative 5 over negative 5, right? Minus, now we got to do product rule. So derivative of the first one, let's put a round bracket. 2x tan x minus x squared secant x squared. Secant squared x. This one, f prime of x. Okay, another product rule. So 5, put it outside. Now let's do the product rule. So what was sine x? It was cos x, right? So cos x squared, because there's two of them, plus, now we got to take the derivative of cos x. So this is sine x. But what was sine? Sine was just, sorry, did I say sine? Derivative of cos, right? Cos, derivative of cos is just negative sine. So let's take out this, let's flip this, and just make this squared. So it's cos squared minus sine squared. Plus 4, what was cosecant? Cosecant was negative cosecant x, cotangent x. Cosecant x, cotangent x. Quite simple. Here we have a quotient rule one. F prime of x is equal to, so it was the derivative of the first one, right, the top part. So this is our g of x, h of x, and so what we're looking for is g prime of x, h of x minus g of x, h prime of x over h prime of x squared, right? So a g prime of x is just cos x times 3 minus 2 cos x minus, what's g of x? Sine x. Derivative of 3 minus 2 cos, 3 is 0. Negative 2 is negative 2 cos x, but cos is just negative sine the derivative of it, as we know from here. So it's just going to be 2 sine x all over 3 minus 2 cos x squared. Let's do a chain rule 1 too. Let me make one right now. Let's say f of x is equal to cos x times sine 2x squared. Okay? So this is a product rule mixed with a double chain rule, right? Because we have, this is the one big function, then we have a smaller function inside that has a smaller function inside, right? So let's do it now. Cos x. So derivative of cos x, negative sine x, right? Right there. You might want to take a screenshot of this. Negative sine x sine of 2x squared plus the first part, right? Now we got to take the derivative of that. So it's going to be 2 times sine of 2x. The power is subtracted 1, so it becomes 1 times the derivative of the sine x, right? So what does the sine x become? The sine 2x becomes cos, right? It becomes cos 2x. So cos 2x times the derivative of the inside of that, which is just derivative of 2x. Derivative of 2x is just 2. And that would be the answer. If you guys have any questions or need more practice problems, please leave them in the comments. I'll get back to you. If not, have a good rest of your day.